So we're going to look at dividing radicals today, and I'm going to show you two different methods that you can use to do this, okay? So first thing I want you to just notice about this paper is that these problems are all the same, okay? So we're going to do the same three problems using two different methods just to show you how they work, okay? And you can use either one. It doesn't make a difference, all right? Now, the other thing that I just want to make a note of is that when you talk about dividing radicals, there is this rule in math that says you're not allowed to have a radical in the denominator of a fraction, okay? And you have to do this process called rationalizing the denominator. We are not going to worry about doing that in this class, okay? So that's not something that we have to do. That's something that, if you go on in your next class, you might cover that a little bit. But for the sake of this class, we're not going to worry about rationalizing the denominator, okay? So we're just going to look at simplifying. So let's take a look at these. All right, so we're going to look at this first guy here. Method one is that you simplify just like you would a fraction. So you simplify the like parts like you would a fraction, okay? So like this guy, see how this is like 10 over 2? So just like how you'd simplify a fraction, you find a number that evenly goes into both of those. So like 2 will evenly go into both of these numbers. So I'm going to divide top and bottom by 2. And that's going to give me the square root of 5 on the top and the square root of 1 on the bottom. Right? And then I just want you to check if you have any perfect squares. Like 1 is a perfect square. So we can take that out of the square root. The square root of 1 is just 1. So that's the same as the square root of 5 over 1 or just the square root of 5, right? Because you don't have to put the 1 in the bottom. That's optional. All right, and that's it. Okay, second one. So this guy, I want to simplify like a fraction. So I'm looking for a number, any number that'll evenly go into both of these. So for this one, I'm noticing 5 will work. So 15 divided by 5 is 3. And then 20 divided by 5 is 4. Okay, and then I just want to check and see if I have anything that's a perfect square that I can simplify. And I actually do, right? The square root of 4, that's exactly 2. The square root of 3 is going to be some decimal, right? It's somewhere between 1 and 2. But I know that the square root of 4 is just regular 2. So that is going to be what my answer will be. All right, and then we've got a third one here. So square root of 3 over 6. And I'm noticing 3 will go evenly into both of those. So I'm going to divide top and bottom by 3. That gives me the square root of 1 in the top and the square root of 2 in the bottom. And I'm noticing that 1, that's a perfect square, right? So the square root of 1 is just 1. So it'll be 1 over root 2. Okay, notice the difference here on this one. There was a 1 in the bottom, so we could get rid of it. But when the 1's in the top, you can't do that. That's a different thing. Okay, so make sure that you don't get rid of any 1's that are in the top. All right, and that is fine for an answer. Like I kind of mentioned before, most of the time you don't usually leave radicals in the denominator, but we're not going to worry about that for this course, okay? So for this year, you don't have to worry about that. So that's the first method that you can use. So now we're going to look at the second method. We're going to do the same 3 problems and see where we get, okay? So for the second method, this one, what you're going to do is you birthday cake both of your radicals. And then we're going to cancel things out just like we did when we did our exponent rules, and we cancel like any x's that were common top and bottom. So let's take a look at this first one. So the square root of 10 and the square root of 2. So I'm going to start down here, take square root of 10 and birthday cake it, right? So 2 goes into 10 5 times, 5 goes into 10 once. 5 goes into 5 once, and there's my candle, right? So no pairs, that's okay. And then 2, well, 2 doesn't really birthday cake, right? It just goes into itself once. So what I'm going to do is I'm going to rewrite this fraction, right? And I'm going to write it with just these numbers. So the 2 and the 5 were leftovers without a pair, so those go on the inside. And on this guy, no pairs, so that stays on the inside, right? And then what you can do from there is you can cancel things as long as it's the same number and they have to be in the same spot. So they have to both be inside or both be outside of your radicals. So these guys, these 2's are both inside radicals, so I can cancel those out. And then I'm left with the square root of 5, and on the bottom we just put a 1 as a placeholder. But the square root of 5 over 1 is just the square root of 5, right? So notice that we got the same answer using both methods. All right, let's look at the second one. So square root of 15 over the square root of 20. Okay, so I'm going to start by birthday caking them. So here's 15. Let's see, 5 goes into 15 3 times. And then 3 goes into itself once. And then birthday cake 20. Let's see, 2 goes into that 10 times. 2 goes into that 5 times. And then 5 goes into itself once. So that one I'm going to have a pair on. Okay, so 15 was in the top, so I'm going to start here. No pairs, so they both stay on the inside. And then these guys, I've got a pair on the outside and a leftover 5. Okay, and then from there, I can cancel these guys because they're both 5's and they're both inside the square root. This 3, that's still inside the square root, so it's still going to stay a square root of 3. That's not in a square root, so it just stays a 2. And there we go. And notice again, same answer that we got up here. So either way that you want to do these is perfectly fine. All right, let's take a look at the next one. All right, so we're going to do the same thing. So I'm going to birthday cake 3 and 6. So 3, that's a little baby one. It's just 3. 6, I know 2 goes into that 3 times. 3 goes into itself once. So I can write this square root of 3 and the square root of 2 times 3. These guys will cancel out because they're both inside the radicals. So that's going to work out to 1 is a placeholder in the top and the square root of 2 in the bottom. Okay, same answer we got up here. So you can use either method. It's just a preference, whichever one you like better. So if you're good at simplifying fractions, then you might want to do it this way. If you're really good at birthday caking, you might want to do it this way, and either way is fine. Okay, now one quick thing that I just want to make sure that we point out, okay, if we had a problem like say we go through and we do all of our birthday caking, right? And after we birthday cake, we have something like 2 times the square root of 3 on the top, and then on the bottom, we have 2 times 5, okay? See how we've got a 2 in both of them, but in this one, it's outside the radical, and in this one, it's inside the radical, right? So this would be an example where this does not cancel. So it does not cancel. All you could do with this guy would be to just put it back together like that. Okay, so if one's on the inside of the radical and one's on the outside, even though they're the same 2, right, you can't cancel them out because one's technically a square root of 2 and that's a different number. Okay, so this is just one little extra example to watch out for. Right, and then the other thing I just want you to be aware of is that because we are not, right, so remember I said that we're not allowed to leave square roots in the bottom, but we're going to ignore that part. Okay, because we're kind of ignoring that part, sometimes you might get a different answer from somebody else where both of them would be right. Okay, so I'm going to be a little bit flexible with some of these answers because we're skipping that part. So it's sort of like how like 1/2 and 2/4, right? They're the same thing because you simplify 2/4 to 1/2. Well, since we're skipping the simplify part, I would take either one of those answers is basically what I'm saying. All right, so just be aware that you won't necessarily always get the exact same answers as someone else.